So we will be starting section 4.6 today. We will spend a couple days on this section looking at some other methods for solving quadratics. Last week we solved using what technique? Using factoring, yes. So factoring is one option for solving quadratics. It's not the only one. All right. So we are going to look at the process called completing the square. It has several steps. We're actually going to practice the last few steps first, get that figured out in our minds before we add the more complicated first few steps. Okay? Tomorrow we'll look at the second objective, which is to look at completing the square as a method of rewriting a quadratic into vertex form. So our first ones, if you look at the four examples, notice that there are several pieces in them. We have some constants, just plain numbers. We also have some pieces that have an x squared in them. Okay? But in none of these four examples do we have just a plain x term. So again, if you think about your quadratic equation, right? We don't have that middle bx piece. If you recognize that type of problem where the middle term is missing, you can solve this using square roots. Okay? And again, this is part of those last steps in that whole completing the square process. So my first step that I have to do is to isolate the squared part. And the only thing in this case that's being squared is the x. That means I have to get rid of all the other pieces. So my first step would be to subtract the 10x, or sorry, the 10. Second step would be to do what? Divide out the 4. We get it down to where we have x squared equaling 9. And to undo an x squared, to undo something that's being squared, we can square root it. We are going to square root both sides. And the key thing here that a lot of students forget is that they need to have the plus minus on there. Okay, anytime you physically draw in a square root to solve an equation, you have to consider both the positive and the negative roots. The left side cleans up to be just a plain x. The square root will cancel the square. On the right side, we end up with positive and negative 3. And you can plug those back in and check to make sure they work, just like we did the last week. Okay? What would we do on the next example? Add the 5, which gets us 30, and dividing by 3. So now we have x squared equaling 10. Not as nice because it's not a perfect square, but we can still square root both sides. We end up with x equaling positive and negative square root of 10. Are there any perfect square factors in 10? Okay, then that's all we can do with it. That's our answer. Okay? Go ahead. I'm going to pause the recording. I want you to try the next two with your partners. All right. Checking our next one. Did you add the 10 over? And divide it by 7? So what did you get for a solution?
X equals positive, negative.
Good. All right. For this one, subtracting 9 over and dividing by 2. Then we square root both sides. We end up with x equaling. Good. Okay? All right. So that's actually the last couple steps in our completing the square process. We get something down to where we can just square root both sides. All right. The next type we're going to look at are what happens if we have a perfect square trinomial. We did some factoring with these last week. We are looking at that side. Does it fit that pattern that makes it a perfect square trinomial? If it does, it has to factor into two identical factors, yes? What would our factors be? X and X, what are my numbers? +2 for both, yes? So does it fit the perfect square trinomial pattern?
Yes.
Yes. So what we're going to do, we're going to factor that perfect square trinomial, but I want you to write it as something squared. Okay? So instead of writing x plus 2 times x plus 2, we want to think of it as x plus 2 quantity squared. The right-hand side has it equaling 25. Now we talked last week when you are solving by factoring, you have to have it equal to 0. You do not have to have it equal to 0 when you're solving by square rooting. Okay? Our next step, we want to square root both sides. So we have x plus 2 quantity squared. We are now square rooting it. It cancels the square part. On the right-hand side, the root of 25 is 5. So we get plus minus 5. So we actually have two equations. We have x plus 2 could equal a positive 5, and we have x plus 2 could equal a negative 5. We need to solve both of those. All right, so I'm going to subtract 2 over, and I end up with x being 3 or negative 7. Questions about that one? All right. Does this fit the same pattern? Is the left side a perfect square trinomial?
Yes.
Okay. What are the factors?
-7.
X minus 7. Good. Quantity squared. Okay. Now, that whole side is squared. We can undo it by square rooting. So now I end up with x minus 7 equaling positive and negative 5 again? Okay. So again, picture the two equations that you could write. X minus 7 could be 5, or x minus 7 could be negative 5. What are we going to get for solutions? 12 for that one, or 2 for that? Now, could you take those and plug them back into the original problem? Make sure they work? Okay. Questions on what to do when they're already perfect square trinomials? We're slowly leading up to that completing the square process, okay? For the first ones, we already had it written like the blue here. All right, it was already something squared, and we just went and square rooted. For this one, we had to actually factor it down to see that it was something squared, but then we could use that square rooting technique. What completing the square, the whole process, what it does is it creates perfect square trinomials. It forces the left side of your equation to be perfect. Okay? So, looking at this first example here, is it a perfect square trinomial right now? No. It's not going to factor into two identical factors. So, our first step, we want to move the constant out of the way. This positive 2 is not the right number to be there. So I'm going to move it to the other side, which gets me x squared minus 4x equaling negative 2. Our next step says to add b divided by 2 squared, and I have that up here as well. That's the perfect number that will make this into a perfect square trinomial. Okay? The one thing to keep in mind is you have to add it to both sides. We have a balanced equation. The two sides are supposed to be equal. If we change one by adding a number to it, and we don't change the other side, it's no longer balanced. So, we need to calculate what is b divided by 2 squared. I'm going to take my middle term. Remember how we have ax squared plus bx plus c? So b is the number in front of x. I'm going to take that number, in this case it's a negative 4. I need to take half of it, divide it by 2, and square it. What do we get? We get -4 divided by 2 is -2. Squared gets us a 4. That's the perfect number. That's the one that's missing. So what I'm going to do is I'm going to add 4 to both sides. I'll put it down here so it's a little clearer. X squared minus 4x plus 4 equals -2 plus 4. I added that 4 to both sides. Is the left-hand side now a perfect square trinomial? Yes. Which means it will factor into what? Good. X minus 2 quantity squared. On the right-hand side, we have a -2 plus 4, which is just a 2. All right. And now it's just like the ones we've been solving. We're going to square root both sides. We end up with x minus 2 equals plus and minus square root of 2. 2 is not perfect. I'm just going to leave it like that. My final step, I'm going to add this 2 from the left side over to the right side. So I'm going to end up with an answer that looks like this. So I added the 2 to the left, to the right side, and then I have to add and subtract a root 2. I am fine with you leaving it just like that. Okay? But keep in mind, that is 2 answers. You have 2 plus root 2 and you have 2 minus root 2. Those would be 2 separate numbers. If you calculated them in a decimal format, you'd have 2 distinct answers. Okay? All right. What's the first thing I'm going to do here? Move my constant out of the way. 3 is not the right number. Move it out of the way. I'm going to pause this. I want you guys to talk at your tables. What is that missing number? What should it be instead? So we talked a minute ago about moving that 3 out of the way. We're going to add it to the right-hand side. What is my missing number? It should be a 9. And how we got that 9, we take our b term, 6 divided by 2 squared. 6 divided by 2 is 3. 3 squared is 9. That's what I need to add in here to both sides. Okay? I have forced the left side to become a perfect square trinomial. The right side adds up to 12. What's my next step? Now, can I simplify the square root of 12? This is why I had you do that worksheet last Friday. What can I do to it? Think of it as 4 times 3. So when I square root it, it becomes 2 root 3? Okay, so I have x plus 3 equals plus minus 2 root 3. And last step, subtract the 3 over. So my final answer is x is -3 plus and minus 2 root 3. We good with that? Okay, we're going to stop there for today. I expect to see work shown. We're not doing this stuff in our head. Tomorrow we will look at what happens when we have a leading coefficient that's not 1, because that does add to our problems. All right, so you are doing day 1 assignment here. Okay.